So our video is about electricity. The electric current is the flow of electricity through different routes. It's kind of like how like a waterfall, like when they fall down and when they meet like rocks and stuff, that they'll flow separate ways. Even though they flow in different ways, they still travel the same. That's kind of like how electricity works. That even though they flow in different ways, that it travels the same way. When you think about electricity, it might be really complicated, but it kind of connects itself to a river fall, or a waterfall, because it's about the same thing. The way that the water flows down the river from a high elevation to a low elevation is about the same way as the electricity flow. When it flows from high elevation to a low elevation, it's called a potential difference. So no matter which route the current or the electricity go, just like the water, no matter where they go, the amount of water or the amount of current, electricity traveling through that point will be the same. The concentration of it wouldn't change as it goes through different part of it. So no matter which way it goes, it always have the same amount of substance. Okay, current and wave. Current is just the flow of charges from, let's say, a battery to a light bulb. Well, the thing is, if you connect the light bulb to the battery, which one will light up more? You probably think maybe the first one will light up more because it's closer to the battery, but it doesn't work like that. It works more like how wave and then electricity works is they travel through this wire at a constant speed, not like they all travel the same. No, they all have to flow in the same direction in the same way. So no matter how far apart these light bulbs are from the battery, they will all be the same intensity of light and radiation, because electricity travels in the same order, in the same amount, in this circuit, which is called the series circuit, which connects the battery to the light bulb to another light bulb back to it. They just circulate more. The potential difference, or kind of like potential energy, from the top of this waterfall to the bottom of this plane is the potential change in energy. And that potential difference or change is same as voltage in electricity, which is the change in electricity from a different point, from point A to point B. There's a difference in voltage. That's why the electricity travels to this light bulb, which makes the light up. Since the same amount of electricity enters it, that means the same amount will have to exit it. So that means that at each point of this wire, the electricity current will be the same and constant. From this voltage drop of electricity is transforming. The electricity is being converted to the form of being in the battery to a form of light. Electromagnetic waves, they're the wave emitted by a charge that travels through space in a transversal wave that's perpendicular to the wave that emitted them. Electromagnetic wave is connected to magnet, since it'll compass when there's needles, and when waves such as electromagnetic waves travels by, it changes the needle's position and it affects the magnetic field. There's two types of waves I'm going to talk about. One is AC, which is alternating current, and one's DC direct current. In alternating current, the electrons move back and forth, which produces this wave that travels really fast through the air. In direct electrons, they don't really do any back and forth moving. they go straight in a circuit. They go straight from one position to straight to another position. And waves move through air just like any other waves would. They wouldn't, like the electron that produces those waves, those don't move straight to the substance they're gonna like reach. Only the waves that they produce reaches the substance that whichever you're doing. Like saying for light bulb, this battery produces the electrons, which is produces in waves that's traveling through this wire to this light bulb. The electrons in this battery are not actually being transferred to this light bulb because it's moving really fast. If it was actually being transferred to this light bulb, it will probably break the light bulb because this substance, whatever it was, electricity, is moving really fast toward this light bulb. Transformers is more of a substance that take a really high voltage electricity to a low voltage that you can actually use in your everyday life, such as the computer electricity, like their batteries and stuff, because the voltage that's actually being produced by the plug that you're plugging into the wall is much larger than that. It's much larger that it can't really fit and be used in this computer. So it has to have a transformer that will transfer this big wave into a smaller one that you can use. Also, transformers, they will also be used like as a business, like how they want to save money, which they will produce a big wave and go to each house, in which the wave that goes into the house is smaller than the wave that they produce. That way it saves their money. Solenoids are these circles of wires that are continuous, and in each field these solenoids can be connected to other loops, and together they make a greater magnetic energy and strength and like greater electric field. So solenoids are basically wires that are in a loop that connect to other loops that create a greater magnetic field strength. Capacitors are small devices that could hold a large electricity. They're made of two conductors, each with the opposite charge, one with a positive and one with a negative, and they are separated by an insulator, which could store a lot of energy. And some of them are really small, like even though they're really small, they can still store a lot of energy. And Benjamin Franklin, one of our history inventors, he actually experimented with lightning with some, it's kind of related to capacitor, because he kind of made this device that actually attracts and put the lightning, like attracts the lightning. And this is going to move to one of our subject today, which is Tesla coils that have electricity produced in them, which they have conductors that has opposite charges in that, and they produce this electricity.